A point is on the terminal. This point is a terminal point of angle theta in standard position. So first of all, if we label where -1, -4 is, it would be down there. If we drew that back to the origin, we would get an angle in standard position. Now, if we have an angle in standard position, does it make sense that this would be our reference angle right there? I'm going to call these questions triangle questions. So if you come in for help and you're like, oh, I can't get this one, I might say, oh, that's a triangle question. And by a triangle question, that's going to help you because if you draw a triangle back to the nearest x-axis, so I'll do it here in green, with your reference angle. So your triangle will always include your reference angle, and that's a right-angled triangle. What do we know about that triangle? I know that this length is 1. I know that this length, even though it goes down 4, I'm going to label it as positive 4 because that's its actual length. I know that those are the lengths. And if I do a squared plus b squared equals c squared, I can figure out the hypotenuse, and you will get good at doing a squared plus b squared equals c squared in your head. Can you see how I just 4 squared is 16, 1 squared is 1, add them together, get 17? So once you've drawn your triangle, the question is, can we write all 6 trig ratios? Yes. We need to write sine of theta, cos of theta, tan of theta, and all 6 reciprocal ones, cosecant of theta, secant of theta, and cotangent of theta. The reason we draw our triangle is because we know SOHCAHTOA, or what was that other one? CHOSHAKOW. Here we go. Don't remember that. SOHCAHTOA says that if I have this reference angle, what's sine equal to? Opposite over hypotenuse. So I can write, I'll do that one in blue, 4 over root 17. It's in quadrant 3. Will sine be positive or negative? Negative. So I like to write my ratio first and then think about my cast rule to find out if it's going to be positive or negative. And since it's in quadrant 3, my cast rule says that only tan should be positive in quadrant 3. For cosine, adjacent over hypotenuse, also going to be negative. And for tan, opposite over adjacent, 4 over 1. You could leave it just as 4. I wrote it as 4 over 1 so I could really show that. And also, when we do the reciprocals, our answers are going to be as follows. What's the reciprocal of 4 over root 17? Going to be root 17 over 4. Because it's negative over there, it'll be negative over there. And you know how in grade 11 you always had to rationalize the denominator? They assume you know how to do that in grade 12. So you are allowed to leave your answer with the square root of 17 on the bottom. Okay, in multiple choice questions, often they'll have it rationalized. In your answer key in your textbook, often it has it rationalized. But on your exam or on your quizzes, if you left it as negative 4 over root 17, that would be fine. And it's kind of nice because when you do the reciprocal, well, then, I mean, this one's already rationalized. And same thing here, negative 1 over 17. Now we're going to get negative root 17 over 1. And part of the reason I left it as 4 over 1, so that when we do the reciprocal, it's really easy to do. So anytime you can draw a triangle, you can figure out nice. It's robotics. Building a robot so that it can drive you around school. Very nice. should ask him how well it does on the stairs. Okay, so the question you can do for this one is number 8. And now you can try those ones for a bit.